So for number 58, we've got an elastic collision, but it's kind of an interesting one. You've got a zero point 0.4 kilogram blue bead sliding down a curved frictionless wire starting from point A, and then at point B it collides with a zero point 0.6 kilogram blue ball at rest. In the diagram, they look the same. Find the maximum height the blue ball, that's the one at the bottom, will rise up the wire after the collision. So first of all, we have to figure out how fast the bead, which is released from the top, is going to be moving. So just using energy, potential energy equals gravitational potential equals kinetic, we can plug in our numbers and we can figure out it's going to be moving at 5.42 meters per second when it collides with the ball at point B. Now we're looking at an elastic collision before and afterwards. We've got the bead moving at 5.42 meters per second, colliding with a stationary ball, 0.6 kilograms, and afterwards we assume the bead's going to bounce back and the ball's going to move forward. What we remember in elastic collisions is that both momentum and kinetic energy are conserved. So first of all, writing our momentum equation, the momentum of the 0.4 kilogram ball has to equal the momentum of the 0.4 kilogram ball afterwards, plus the momentum of the 0.6 kilogram bead and the ball together. Sorry, I said ball twice on that one. We also know that in elastic collisions, there should not be any energy dissipated, at least in perfectly elastic. So what are we assuming in this case? The kinetic energy before, which is the kinetic energy of the bead before the collision, must equal the kinetic energy of the bead after the collision plus the kinetic energy of the ball. We have two equations with two unknowns. Our two unknowns are the velocity of the bead and the velocity of the ball. You can rearrange these and solve these, or use a simultaneous equation solver, and you'll discover the final velocities of both of these. The bead is going to be bouncing back at 1.08 meters per second. The velocity of the ball after the impact is going to be moving forward at 4.34 meters per second. Finally, the last question, if this ball is now moving after the collision initially at 4.34 meters per second, how far up the ramp here will it go? In other words, what will be the final height? Well, to answer that question, we have to again do a little bit of work. We have to figure out how far this bead's going to go before it's going to stop and then go back down again. So again, we're going to use energy. In this case, we're starting out with kinetic energy, trying to figure out the maximum gravitational potential energy. All of it's going to be converted. Plugging in our numbers, our velocity is that 4.34 number we have right here. That's going to go down here. And we're going to try to figure out the height that it's going to go to. Solving it, we should discover the final height should be about 0.958 meters up that other side. Hopefully this helps. Enjoy your evening.